Good morning, statistics students. I'm gonna do the first problem from start to finish on the review worksheet. It deals with testing whether a training method reduces the time a runner runs an 800-meter race. Because the contestants or runners are running two different races, one before the training and one after the training, because they're the same ones, called a matched pair test, and we use the term mu difference, and the mu difference symbol is like this. So mu and then with a D, and you'll see me use that when we do the null hypothesis and the alternative hypothesis. But again, when I read through the problem, see, quite often you're going to see a time before or a time after training. So you're going to see this before and after kind of situation, and that's a clear sign that this is a mu difference problem or a matched pair problem, as the book will call it sometimes. So what are our requirements? Well, we have to have a random selection, and now it says from a normally distributed population. Therefore, we have no restrictions as far as sample size or any of that. Normally, it would have to be a sample size of 30 or more, but because it's coming from a normally distributed population, so I'm just going to simply underline randomly selected from a normally distributed population. So that means requirements met. Check. So we've got that taken care of. Now it says down here, using a 0.05 significance level, test the claim that the training helps improve the athlete's time for the 800 meters. So we have to think about what that really means numerically. We want this number to go down, and if we're always going to be subtracting before minus after, that means we want a positive value, because if this time goes down, that means when I subtract, I will get a positive value. So the first thing we're going to do is create our difference list. And so our difference list here, 117.4 minus 118 is negative 0.6. And then 118.7 minus 117.4 would be 1.3, positive this time. And here we have 2.4 positive, and then we have a negative 0.8. Then here we have a positive 1.8. Here we have a negative 0.1. And then 117.4 minus 113.8 would be 3.6. And then the last one would be a 3.9 reduction. So understand, this can be confusing. Usually if I'm trying to reduce something, it's taking away or something like that. But remember, in this situation, if I'm reducing it, smaller number here, so when we do the subtraction, we want a positive value. As compared to if we were doing an SAT and we took a prep course, we would want our number to go up, and so then we would want all of these numbers to be negative. And in another track setting, if we were trying to jump farther in the long jump, we would want these numbers to be farther as well, and then when you subtract, you get all negative numbers. So in fact, these negative numbers are not, that's kind of indicating that the training hasn't helped at all. But anyways, that's beside the point. Let's do our test here. So we're going to go through all of the things that we normally have to have. So first of all, a null hypothesis. It's going to mean mu difference is equal to 0. In these match pair problems, it's always going to be that. And then your alternative hypothesis is going to be the mu difference. Now, because this is going down, we would like to see positive values. We're going to say greater than 0. Greater than 0 implies positive, less than 0 would be negative. So in our SAT question, or if this was a long jump or a shot put or discus and we wanted farther distances, our training technique to test this would need to be less than 0. So then we have a critical value. And just so you know as well, this is a t-test. So I'm going to write that up here because you have to, it's not two sample, it's not any of those, it's just a straight simple t-test. And I've put all that information on your answer sheet, so you'll see that. And then we have our test statistic and our p-value. And then our interval. And let's see here. So our picture needs to look like this. And because this is greater than, it's a right tail. And in this, it says we're using 0.05. So now we're going to go to inverse inverse t. So second bars, number 4, inverse t. The area that we need is the area to the left. So we're going to put in 0.95. And then degrees of freedom are 8 minus 1, which is 7. And then paste and calculate, and we get our 1.895. And so I'm going to put that over here as well. And remember, this is kind of the line in the sand. If we're more than that, we're going to reject. If we're less than that, we'll fail to reject. And now we need to do our test statistic. But first, I need to go to stat and check the lists out. And what I'm going to do is, so I don't waste time, I'm just going to enter my values here in list 3. Later, I'll have to make an adjustment for that. So negative 0.6. Remember, you have to use the negative button, not the minus button. The minus button will give you errors. You'll get extremely frustrated. Now I always check, I know I have 8 values in there, that's how many I'm supposed to, so that's good. So now I need to go to stat and then over to tests. Remember, I'm doing a t-test. We're using data. That should be 0, that matches your null hypothesis there. We're using list 3, so I'm going to go choose list 3. You can use list 1, list 2, list 3, whatever you choose to. Frequency is always 1. Greater than is already chosen, and that's what we have there. And then calculate. And so in this problem, our test statistic is 2.227, and our p-value is 0.03. And I'm just going to round to 1. And then that's more than that, that's less than 0.05, so this is going to be a reject. But since I have the calculator up, I'm going to go ahead and do an interval as well. So we go to test, and I need to do a t-interval, number 8. I'm going to use the data again, it's list 3, frequency is 1. Now my confidence level will be 95, 1 minus the 0.05 significance level. And there's my interval. My interval is negative 0.09. Mu difference is what I put in the middle. to 2.96. This brings up an interesting problem or an interesting situation. We have not had very many of these. You need to realize that as a result of these two, we have a rejection of the null hypothesis, mu difference equals 0, which indicates that we have convincing evidence that the training program works. Now, also, the p-value is less than the significance level. So again, that verifies that. However, in our interval, 0 is included. And we would say not significantly different. Now, if I were to put it on the picture over here, we're going to be like here, and that would be the test statistic. So just be aware of that. That's how that works sometimes. Very infrequently, but every once in a while, this situation will come up. And so be aware that that's possible outcome. You would write, we have convincing evidence that the training helps improve the athlete's times for the 800 meters. You have that written down on your answer sheet and as well as all of the rest of it. But I wanted to highlight all of that. You'll have 3 more problems, 1 more of these, and then 1 2-sample T and 1 2-prop Z test. So another one of the mu difference problems, a 2-sample T, and then the 2-prop Z test. One of the things you need to get from this section and looking at these is how do I tell the difference between a mu difference problem and a 2-sample T? All right, have a good day, and I hope you have a good week.